This is problem number 10 on the sample test problems for test number 3. Write a parameterization of a path which starts at 0, -1 and follows the unit circle in a counterclockwise direction. So we'll go ahead and draw our circle here. And the goal is to start at 0, -1. So we want to start down here, which means that's supposed to correspond to t equals 0. And then we want to go counterclockwise. So we should be heading up this way. All right, so we know that the way to make a circle is with sines and cosines. It's not really clear which one we're supposed to do with which. I'll go ahead and plug in x is equal to cosine of t and y is equal to sine of t, and then we'll make changes. So let's just call this attempt 1. And so then we're going to go ahead and plug in t equals 0 into both of these things. And so we know that x is supposed to be cosine of t, so cosine of 0 in this case is 1, and the y is equal to the sine of t, so the sine of 0 is 0. And so that means that my point, x and y, is 1 and 0 in that order. And what I was really interested in was starting at the point 0, -1. Okay, so it didn't work. In fact, it looks like we've got maybe some swapping happening here. We were supposed to start at 0 and -1, and if we kind of swap these two guys here, then at least we'd start at 0 and 1, which would be closer. So let's call that attempt number 2. Okay, so attempt number 2 is going to be x equals sine of t, and y is equal to cosine of t. And so if we plug in here, then I think we'll end up, so we'll draw a line between our attempts. I think we'll end up getting a 0, 1, just exactly swapping those two things. Okay, so that's better. Now we're going to see if we can get that 0, -1 into play. So how are we going to get a -1? Let's go to attempt 3. So the previous attempt was good, so we'll start from there. But what we really want is to make we really want to make this y-coordinate a negative. We want to make that y-coordinate a negative. So how about we just stick a negative sign right in front of the cosine. And if we do that, then I think we'll end up, again, plugging in t equals 0. You get 0 for the x, and you get -1 for the y. So that's good. We've got our starting point. So the only other question we have to answer is, are we going the right direction? We're starting at the bottom at 0, -1, but I want to know if we're going clockwise or hopefully counterclockwise. So to decide which way we're going, what we're going to do is plug in not t equals 0 anymore, but we're going to plug in t equals pi over 2. In fact, you can plug in t equals any number to kind of just see where you are. But I feel like if I plug in t equals pi over 2, well, pi over 2 is a right angle, 90 degrees. So we're either going to land there, hopefully, or maybe we'll land over here. But either way, we'll know where we are. So let's see if we can figure out which way we're going by plugging in t equals pi over 2. Okay, so we know that x, according to this, is equal to the sine of t. And the sine of pi over 2 is 1. And we know that y, according to the bottom equation, is negative cosine of t. So negative cosine of pi over 2. I guess we could just put that over here. And cosine of pi over 2 is 0, so that's -0, which is just 0. So ultimately the point here is a 1 followed by a 0. So let's plot that point. So 1 followed by a 0 is this one right here. 1 and 0, and that corresponded to t equals pi over 2, which means I think we're heading in the correct direction. In this case, we're going, we started at point number 1, started down here at point number 1, and then second point that we were interested in was there, so we are in fact going counterclockwise around the circle. So I think our attempt number 3 is the final version of things. That right there is your parameterization. I suppose the last thing we should say is the values of t. So we'll go ahead and write our final answer here. X is equal to sine of t, y is equal to negative cosine of t. And then we'll go ahead and put a bound here. We decided that we were going to start by plugging in t equals 0, so that should be our starting point. And then how far do you need to go? Well, you could just let it go forever, and it will trace out the circle over and over again. If you just want it to go once, one revolution around the circle, then you should stop it at 2 pi. And of course, with the parameterization stuff, you're welcome to check your answer on the calculator. So we'll go ahead and go into the mode first and go down to right here, and we'll change it to parametric. We'll go into y equals. We're going to type in our two things, sine of t and negative cosine of t. And once we've got that in there, we're going to go to the window. It feels like 0 to 2 pi, that's what we're saying. We should trace out one complete revolution. The t step, that's probably fine. And then in terms of the x's, well, I feel like we were at -1 and 1 all the way around. This was a unit circle we were trying to build. So if we've done this right, then we should get what we had up above here, which is the circle starting at the bottom and going counterclockwise just once before it stops. So let's go ahead and take a look, starting at the bottom and going counterclockwise. And that's exactly what it was supposed to do. If, for example, you were to change the window, instead of going 0 to 2 pi, you went 0 to 4 pi. And we should end up getting 2 complete revolutions. And in order to see that, we're going to go ahead and change this to something that actually traces around. I think that one will be fine. So we had 1 full revolution going 0 to 2 pi. But because we're going 0 to 4 pi, it should trace around a complete second time and then disappear right when we get to the bottom, the end of the second revolution. And it did. And the last thing to say, I think it's important to put in this 0 to 2 pi business, because if you don't, for example, let's suppose that we started it at negative, let's say we started it at -2 and went out to 2 pi. Then instead of starting at t equals 0, which was the bottom, I think we're going to start someplace out there, someplace out there. So let's see if the first point it plots is the bottom. You can see, no, actually, it started way around here. So we'll pause it there and just say it really is important to at least say we're starting at t equals 0 if you want to really make sure that the circle starts drawing from the bottom.